Okay, get this. Picture a volcanic eruption so powerful that it just blasts like 58,000 Olympic swimming pools worth of water vapor
Wow.
straight up into the atmosphere.
Yeah.
That's what happened back in January 2022
Really?
when the Hunga Tonga-Hunga Ha'apai volcano erupted.
Oh, yeah.
It caused tsunamis, a massive lightning storm, like record-breaking stuff.
Yeah, I remember that. It was crazy.
And what's even wilder, scientists might have actually found a hidden warning sign in the data.
Oh,
A seismic wave that showed up just 15 minutes before the main eruption.
that's right.
It's like the Earth was trying to tell us
The
something.
little whisper, yeah.
So for this deep dive, we're looking at an article from the American Geophysical Union
Okay.
all about this secret seismic wave
Right.
and what it could mean for, maybe predicting future eruptions.
Yeah, the article, it actually focuses on a specific type of wave called a Rayleigh wave.
A Rayleigh wave. Okay.
Okay.
So was this like a normal wave or what?
Well, Rayleigh waves usually travel along the Earth's surface,
Uh-huh.
kind of like, when you drop a pebble in a pond,
Yeah.
the ripples spread out.
Okay.
This one, though, was different.
Different how?
Traveled hundreds of miles, picked up by monitoring stations.
Oh, wow.
Far away from the volcano. But here's the thing. It was silent.
Silent.
Nobody on the islands felt a thing.
Wow. So it's like a secret message
Yeah, pretty much.
that only instruments could pick up.
Exactly.
That's pretty wild. What do the researchers, what do they think caused this wave?
So they think it was a fracture, like a crack, forming in the Earth's crust right under the volcano.
Hmm.
And to understand what this means, you kind of need to, know how these volcanoes are built.
Okay.
So imagine like a giant bowl, like a depression at the top.
Okay.
Geologists call that a caldera.
Okay, so a caldera.
And the researchers think that the fracture, that crack, happened right under the caldera wall.
So this crack, it like appeared right before the eruption.
That's what the data's telling us, yeah. And here's where it gets really interesting.
Okay.
They think that the fracture, it opened up a pathway for seawater to seep into the area right above the volcano's magma chamber.
Oh, so you've got cold seawater
Right.
meeting super hot magma.
Exactly.
I'm guessing that's not good.
Not good at all, no. Things are about to get very explosive.
Oh, yeah, that makes sense.
And that's why this discovery, it's so important for these early warning systems.
Oh, yeah?
Like if we could learn to identify these Rayleigh waves, these silent alarms, we could have more time.
To repair.
Yeah.
Okay.
Especially for eruptions that could trigger those, those dangerous tsunamis.
Right, that extra time could be crucial.
Oh, absolutely.
Especially for those islands that are just so vulnerable.
Yeah. Even just a few minutes warning could make a huge difference for, evacuations,
Yeah.
getting emergency teams ready.
But the article also said that scientists, they're still not 100% sure
Right.
about what actually triggered the main eruption.
Yeah, these caldera-forming eruptions.
Yeah.
They're really rare, especially ones that happen underwater.
Right. So much of it's happening underwater. It's tough to get a clear picture.
It's like solving a mystery with only half the clues.
Yeah, exactly. So we've got this amazing seismic data, but still some gaps in the visual timeline.
That's right.
But even with that, the researchers were able to zero in on this Rayleigh wave
Right?
as a major event before the big eruption.
Exactly, like a tiny clue.
That leads to a much bigger story.
Yeah.
So even though scientists weren't using this type of analysis back in 2022,
Yeah.
when Hunga Tonga-Hunga Ha'apai erupted, are you saying that future eruptions might actually be predictable?
That's the hope.
Wow.
It's still early, We need more research to know for sure if these types of Rayleigh waves are reliable predictors, but the potential is there.
It's pretty amazing. This could be a game changer for, how we monitor these underwater volcanoes.
Absolutely. It just shows how much we still have to learn about the Earth.
Yeah.
And those incredible forces under our feet.
Well, let's dig a little deeper into what happened during the eruption.
Okay.
Like the power of this thing. I mean, it's just mind-boggling.
It was intense.
We're talking a tsunami that went across the entire Pacific Ocean.
Yeah.
And then the lightning storm. The article said it was the most intense ever recorded.
Yeah.
So 200,000 lightning strikes from a volcano. Like, how does that even happen?
Well, it's thought to be from the friction of all the ash particles colliding up in the plume.
So the finer the ash?
The more lightning.
Wow.
And with Hunga Tonga-Hunga Ha'apai, the ash particles, they were incredibly fine.
Okay.
Which explains that intense lightning storm.
So this eruption, it really was a perfect storm in terms of, power and all the electrical activity it generated.
It really was. It really was something else. Scientists are going to be studying this one for years.
Yeah, no kidding.
Yeah.
I mean, it really makes you realize how, powerful nature can be.
It does.
Keep thinking about that Rayleigh wave, traveling for hundreds of miles,
Totally
silent. If people on those islands couldn't even feel it, how did scientists even pick it up?
Oh, that's the amazing thing about our monitoring equipment nowadays, It's incredibly sensitive, picks up even the faintest vibrations, stuff we humans can't even sense.
So it's like we have this sixth sense.
Right.
That can pick up things we just wouldn't normally notice.
Totally. And in this case, that sixth sense gave us a crucial 15-minute warning.
Yeah. Wow.
A window to actually do something, maybe make a difference in how we prepare and respond.
It really shows how important these monitoring systems are.
Absolutely.
Especially in areas where, there's a lot of volcanic activity.
For sure. Early detection, that's key when you're talking about mitigating risk from these natural hazards.
The article mentioned that scientists still aren't totally clear on exactly when the eruption started.
Yeah.
I guess that's got to be pretty tricky to figure out, right? Especially with an underwater volcano.
Right. I mean, with submarine volcanoes, most of the action's happening below the surface, right?
Yeah.
Out of sight, like trying to put together a puzzle, but some pieces are missing.
So we've got this great seismic data, but we're still trying to fill in some of those visual blanks about, when exactly everything happened.
That's right.
But even with that, researchers were able to single out this Rayleigh wave.
Yeah, like a key event that happened before the main eruption.
That's so cool. It's like a tiny clue that unlocks this much bigger picture.
It is.
So even though, like we said, scientists weren't using this kind of analysis back in 2022.
Yeah.
Are you saying future eruptions might be, actually predictable?
That's what we're hoping for.
Wow.
Yeah. We need to analyze more data from other submarine eruptions, see if we find similar patterns.
So seeing if this Rayleigh wave is unique to Hunga Tonga-Hunga Ha'apai?
Yeah.
Or if it's something that happens with other underwater volcanoes too?
Exactly. The more data we get, the better we'll understand how all this works. And of course, we need better models.
Oh, yeah.
That can really accurately simulate these eruptions, factor in all those variables, the magma, the seawater, the geology of the area.
Right. Lots of moving parts.
It is, yeah.
Sounds like there's still a lot to learn.
Oh, for sure.
But the potential payoff could be huge, right?
It could be.
If we could get reliable early warnings for these kinds of eruptions.
You could save so many lives.
It really highlights why research like this is so important.
Absolutely. And why we need to keep investing in volcano monitoring.
Yeah, it's pretty amazing to think that we could be on the verge of this whole new era of volcano monitoring.
It really is.
Where we're not, just reacting to eruptions after they happen.
Right.
But actually getting ahead of them.
It's a total shift from being reactive to proactive. And it could totally change how we deal with volcanic hazards.
So let's say just for a second that we do, create these advanced warning systems.
Okay.
What would that actually mean for the people living near these volcanoes?
Well, most importantly, they'd have more time to prepare.
Yeah.
We're talking evacuations, securing infrastructure, getting those emergency response plans, into action.
I mean, that extra time, it could literally be the difference between, life or death.
Absolutely.
Right.
And it could help reduce the economic impact, too.
Right.
If communities know when an eruption's likely, they can take steps to protect businesses, crops, other assets.
So it's not just about saving lives. It's about making those communities more resilient.
Exactly. And it's important to remember that these benefits, they go way beyond just the area right around the volcano.
Right.
Think about it. Tsunamis from those underwater eruptions, they can travel for thousands of miles.
Yeah.
Affecting coasts all over the world.
So this research, it has global implications.
Exactly. It just shows how connected our planet is, you know, and how important it is that we work together, internationally to address these challenges that affect all of us.
Well, I think we've covered a lot today.
We have.
We started with this, mysterious seismic signal.
Right.
And ended up talking about a possible revolution in volcano monitoring.
Exciting stuff.
Any final thoughts before we wrap things up?
I think this research really reminds us how much we still have to learn about our planet.
Yeah.
You know, there are these hidden signals all around us, just waiting to be discovered and understood.
True.
And as we unlock these secrets, we got to use that knowledge wisely, right? For everyone's benefit.
Well said. And for everyone listening, we hope this deep dive into the Hunga Tonga-Hunga Ha'apai eruption has, made you think about the forces of nature.
Yeah.
And how science can help us understand them, maybe even navigate them a little better.
It's a journey.
Keep exploring, keep asking questions, and never stop learning.